So we looked at definite integrals. So something like this, right? So this means that we have some kind of bounds of integration. So in words, this is telling us to find the area under the curve of x squared from 0 to 2. So the region, which is bounded by the function and the x-axis. Okay, so if this is, say, like 2 right here, right, then we'd be looking for this area right here. But then we also have this concept of an indefinite integral, right? So if we have something like this, where there's no bounds of integration, okay. So this doesn't have like really the same physical meaning. In a way, it's giving us a general formula to find the area underneath this curve, and then we can plug in the bounds, for a definite integral. But in general, this is really just asking us to find the antiderivative with respect to whatever this variable is. And when we do that, remember, as we saw in the video about antiderivatives, we have this constant term, right? And again, this arises from the fact that when we're finding the antiderivative, we're asking what function is this function the derivative of. So in x squared's case, this function is the derivative of x cubed over 3. But then there could always be this constant right here, right? So again, this comes from the fact that if we take the derivative of a constant, we get 0. So there's no real way of knowing what this constant is. We kind of lose this information when we take the derivative and then go backwards with the antiderivative. We lose what that initial constant was. So just as an example, like x cubed over 3 plus 0, x cubed over 3 plus 1, x cubed over 3 plus, minus 7, for example. These would all be antiderivatives of x squared. But sometimes the problem will give us what's called an initial value, which is one of the values of the problem. And this is especially common in like word problems or application problems, where they'll give you some kind of information where you can figure out a point, and that'll help you determine what that constant is meant to be in this particular case. So let's look at a couple of examples of that. Okay, so for example, if we're given that f prime of x is equal to x to the negative 3, and then we're given the value f of 1 is equal to 1, then what we can do is we could first find this antiderivative, and then we can figure out what exactly f is, including the constant in this case, because we have this initial value. So we go ahead and we integrate the derivative, meaning we find the antiderivative, right? So in this case, we're going to take the antiderivative of x to the negative 3. So we're just going to use the power rule here. So remember, this is just 1 over x cubed. Sorry, I'm having trouble getting the writing to pick up this time. So when we do that, we get x to the negative 2 over negative 2. Okay. So in other words, we have negative 1 over 2 x squared. Okay. But then we get this constant term as well, right? So we have plus this constant. So we write plus c. And this is what f of x is equal to. So now when we plug in f of 1, okay, so if we plug in f of 1, we're going to get negative 1 over 2 times 1 squared, so that's just 1 plus c, and then we're told that this is equal to 1. So now we're left with this equation that only has c in it, so we can solve for what exactly c is. So in this case, we just add 1/2 to both sides, and we get that c is equal to 3/2, or 1 1/2. So when we're given the initial value, we're able to actually solve for exactly what f is. Otherwise, we're just left with a constant term, right? So these are kind of like two different questions we'd be asking in these cases. With the definite integral, we're asking the question, what is the area underneath the curve? With the indefinite integral and antiderivatives, we're asking the question, what is that antiderivative? So like if we're integrating, for example, a derivative, then we're asking what is the original function? And again, we lose that information about the constant, but when we get this initial value, we're able to kind of get that information back. So let's do one more example here. Okay, so this one, we have f prime of x equals 2 over x squared minus x squared over 2. And then we're told the initial value of f of 1 equals 0. So again, we're first going to find the antiderivative of this. So we're going to integrate it without any bounds of integration. And then we're going to have the constant term in there. So then we can plug in 1. And then we know that that is equal to 0. And that will allow us to solve for the constant. So we'll go ahead and integrate this. So this one is 2 times x to the negative 3. So this is really like the same one we just did, but now we have it multiplied by 2. So you can just take what we just did on the last one and multiply that by 2. So we'll get just negative 1 over x squared. Or actually, it's going to be, oh, sorry, I guess it is a little bit different, right? This is what we ended up with, but it's not what we initially started with. We started with x cubed. All right, so anyway, so we'll actually integrate this right here. So 2x to the negative 2 minus x squared over 2. Okay, so we go ahead and do that. So we get 2 times x to the negative 1 over negative 1. And then minus x to the 3 over 2 times 3 on the bottom. So 6. Okay, and then we add the c in here. So now we can go ahead and plug in 1, and then we can set that equal to 0. Okay, so when we do that, so x to the negative 1, this is just like having x on the bottom. Either way, we're just putting 1 into it, so it's not really making any difference. So we have negative 2 minus 1/6 plus c equals 0. Okay, so rearranging this, we're going to end up getting that c is equal to 2 1/6, which is going to be 13/6. Okay. So this tells us that our antiderivative of this function with this initial value is then going to be altogether negative 2 over x minus x cubed over 6 plus 13/6 for our final answer here.